Hi guys, today is electrical circuit lecture 5. Today we will learn about really important. What I mean is every single lecture is important, but we will learn about CT and PT. Let's look at the um, subject: voltage source and current source. And potential transformer is a voltage source, and current transformer is current source. Let's look at it, okay? So as you guys already know, I guess previous lecture I already explained the voltage source system and current source system. So let's review quickly, okay? So voltage system is, you can see here. So voltage source system is, constant voltage, supplying the constant voltage. Okay, so it's ideal voltage source, inside of the voltage, source, there's no resistor. You know what I mean? But it's ideally, but it's a practical, there's some resistor. So that's why, as you can see here, here's graph, right? So this is a, voltage source, but this is voltage source. But what I mean is, here, look at that. Inside the resistor is 0. You know what I mean? Voltage source. So it gotta be the output of voltage is 1.7, same. But I said this is ideally, but practically there's some resistor there's exists. So that's why little bit voltage dropped. That is a voltage source. Voltage source main meaning is a constant voltage supply. Okay, so most of what we see is voltage source. Your home or school or hospital or whatever, like for some specific situation, like when you go to the airport, you can see some part of their you can see current source system, or some specific lab test. You can see a current source. Okay, so what I mean is 99% of the system is voltage source, constant voltage supply system. Okay, let's move on. So here, current source is, the inside of current, source system. There's the resistor is, infinity. So that's why there's no the currents cannot come into inside of the current source system. You know what I mean? So that's why the current is constantly same. But I said this is ideal. But so actually practically or real life there's some resistor exists. That's why so the current is a little bit of down. Okay, same concept of the voltage source system. Okay, from now it's important. Let's see more. Okay, so look at that. Potential transformer and transformer is a voltage source system. I will explain why it's a voltage source system. Let's look at it. Okay, look at the guys. So here's voltage power source. Okay, so as you can see, this is transformer. Just you don't need to get stressed about it. We will later learn about the transform part. Okay, just so transformers, basic concept is from V voltage source. You can say this is a generator, right? From here, make energy, some voltage, right? Energy, and move to here, primary part, E1. Just energy, okay? E1, and also here, E2, secondary, part. So this one, this one, this one, same magnitude. You know what I mean? It's the same size, the amount of, you know what I mean, magnitude. But only differences is, oh, you guys remember Kuroipo's law? Input, node 0 here, and output, input, output is the same, right? Look at that. So for what I said, this is the voltage source here. And if it's, you know, so here is also E1. Energy is made, okay? And so V, I will say this is just a V, and here's E1, right? V equal E1. Magnitude is the same, but only differences is page differences, 1A, 0. Because I said, you know, Kirchhoff's law, in and out is the same, right? But as you guys can remember, the voltage is also same. Everything, you know, from the source, everything voltage drops of total value of sum is same, the voltage source. So that's why V minus E1 0. That's why I say 180 degree, you know, differentials. So so look at that. What I meant is I said just simply thinking. I will not explain about the mechanism right now. Just try to understand what I'm saying. Okay. So I said the E1 and E2 is the same, right? So what I wanna say is here, secondary node. You know, there's a load here. Okay. What I mean is here's a load, for example, 100 ohm. Here's, for example, 100 volt is our, you know, generation part, the voltage source, okay? So which means from here, so actually the transformer's efficiency is really good, almost 99.9%, almost 100%, right? So what I'm saying is also here make it 100 volt, and here's 100 volt. It depends on the ratio of turns. You know what I mean? So it could be the rate is gonna be the increased or decreased, step up or step down. Okay, like for example, the ratio is 1 to 10. If it's 100, here's multiply 10. 1000 volt here, for example. But now I will say the ratio is 1.2, just 1 to 1. Okay, same. So what I meant is, look at that. So you guys remember Ohm's law, right? So what I mean is I want to know about now current, right? We now know the load is here. It could be our refrigerator or television or whatever, okay? Just 100 ohms, for example. So here 100, here 100. What I mean is now I current is 1 ampere. Oh, sorry, 1 amperes coming to the right. So what I want to say is why is it the transformer or potential transformer is a voltage source? What I'm saying is, look at that. Regardless of this, you know, load is the magnitude, the voltage is the same. For example, here, if it's 200, 200 ohms, do you think this E2 part is reduced because of the load? No, it only, you know, effective from the tons, but I'm saying is now 1 to 1, right? So it only effective from here, voltage source. It moves to here energy, and it moves to here, okay? Regardless of this load, it doesn't matter here, this part. Sorry, it kind of messy, okay? So that's why I'm saying is this is a voltage source, regardless of the load, constant, you know, voltages, you know, supply. You guys understand, right? Look at that. So what I mean is now we constant supply. So the load is, it gotta be up and down. And this system, we will see this current. So in the voltage system, we will check the current. So checking the current magnitude, we can see, we have too much load, or we it's enough load. We can think it's a voltage system. Okay. I hope you guys can understand this part. Yeah. And if you guys are confused, let me know. Okay. And let's move on more. So now it's a current transformer. We say CT is a current source. You guys may kind of confused about this picture, right? That's why I make it you guys can understand easily. You know what I mean? Or this is also same. This is a CT, So primary side is, as you can see, here's the ton is, 1 ton or 2 ton, little bit of ton. And instead, the secondary part of many tons here. So you can see here, 1 ton or 2 ton, and here's, many tons. To check the, how many currents there is, we want to know, right? It depends on the purpose of how to use it, but we want to know, how much of, how, big is the current is. We want to know it. That's current transformers is transformers purpose. Okay. So look at that. What I'm saying is, why is it current source? Sorry, guys. Okay, let's see. Okay. Give a sec. Okay. Yeah. So guys, so here is a primary part here, right? Only 1 ton or 2 ton. So here the load is, the here the primary part, here the load is here. The line current is here, flowing, right? And we wanna check the, using the CT, we wanna about the how much current, it flows, right? So what I wanna say is, the load, since the load is in the primary side, so the current is it's affected from the load side. What I mean is, for example, if the current is, okay, here's 2 amperes coming here, right? And if it's for example, if it's load is more, its load is more added here. Load is connected like this, parallel, the load and the load. Okay. Load is always connected to the parallel in the real world, okay? Not series. So that's why when the load is, added, we added more load, the current is, so what I mean is the current is gonna be up. Okay. So for example, here, 100 ohm, just load 100 ohm. So for example, you guys, previous lecture, I explained about how to get the parallels, in the parallels, the load values, how to get it, right? Sorry about it. So what I mean is, if it's 2, parallel ohms, 100, each value is gotta be the impedance. What I mean is the load's value is gotta be, decrease if we add more load. Okay, so that's why the current is gonna be up. Okay, so look at that. Since the load is here, right? So current is affected from here, the primary side. But I said the secondary part, I said it moves to here, right? These energies or these currents to moves here, right? So for example, here 2 amperes coming, right? But if it's here's a, I say ammeter, here's a, I want to check it because of current. But if here's just, for example, here's load, 100 ohms now, or 200 ohms now, for example. Now, ammeter is gonna be almost, just for example, almost 0 ampere, but what I mean is 0.1 ohm, or if I add here's load more, do you think, this secondary current now 3 amperes is, it's coming, right? From one side, from primary side to secondary side. The current is coming 3 ampere, right? But do you think you guys here, if I add load more and more, the current is changing? No, current is because of this primary side. It just, gives energy to here, copy, simply copy. Okay, so doesn't matter here's load. But I said this is a current source, right? So look at that. So what happened? So we say in the city, do not open the secondary side of the city. If you open it, the insulation damage is because of too much surge, big voltage. Since because of big voltage, the city is gonna be insulation damaged. Wow, what I'm saying is here, look at that. As I said, if here's load is is we adding more, actually it's gonna, since it's parallel, it's gonna be smaller, right? But as you know, we wanna do this current source is system is I is current is constant, right? But look at that. So voltage is gonna be changed up and down, right? So what I wanna say is here, if it's infinite, we say open. Open means here, if we open it, it's load is gonna be infinite. Look at that. What happened? So look at that. What happened here? I is constant, but load is infinity. The voltage is, really large. So insulation is gonna be, damaged, break it down. So we say never open it in the city, the secondary part. That's what I'm saying. You know what I mean? By the way, you guys will learn about, I mean, if you guys don't, understand right now what I'm saying, it's fine, because just try to understand what is a voltage system and what is a current source system, okay? And if you guys later will learn, I mean, I will explain more about CT and PT more, okay? Just, if you guys more and later learn about the transformer part, you guys will understand exactly what I'm saying, okay? So what I mean is since, lastly, this is a current source system, right? So what I mean is I is constant. But since R is, it gotta be, if we add here the secondary part more, it gotta be, it's changed or up and down, right? So voltage is changing. This is a current system. But the matter is this primary side is, it's affected to energy to here, secondary part. Sorry, it's kind of messy, right? But if we open it here, what happened? I is constant, R is infinity, because open, V is too much English. That's it, today's lecture, guys. Don't worry about it, okay? Just try to understand it, yeah. See you guys.